Welcome. In this video, we will be learning about principal component analysis with a solved example. So first we learn what is principal component analysis. This PCA tries to reduce the number of dimensions in a larger data set using the principal components. We'll try to get the principal components, and these principal components will retain the most useful information. As well, this transforms the potentially correlated variables into a smaller set of features called the principal components. We'll see the algorithm. This is the algorithm. The first step is to calculate the mean for every feature. The next step is to calculate the covariance matrix. The third one is to calculate the eigenvalues and eigenvectors. The fourth step is to compute the principal components. We'll look into this with a simple example. So here we have a data set. This data set contains 4 data points, 1, 2, 3 and 4, and it has 2 features x1, x2. x1, x2 are 2 features, and these are all the data points. We have 4 data points. The first data point contains the feature 4 and 11. The second data point contains the features 8 and 4. Okay. The first step is to compute the mean for every feature we need to compute. So the first feature is x1. We will be computing x1 bar, which is equal to 1 by 4. 4 is the number of data points. And the first feature we have 4, 8, 13, 7. So it is 4 plus 8 plus 13 plus 7 divided by 4 equal to 8. Similarly, we compute x2 bar, that is the mean for the second feature. The second features are 11, 4, 5 and 14. So we will get 11 plus 4 plus 5 plus 14 divided by 4, which is equal to 8.5. The next step is to calculate the covariance matrix. So first we will learn what is a covariance matrix. Here the covariance matrix is denoted as S. S is equal to covariance of x1, x1. So this is in the position 1, 1. Covariance of x1, x2. So this is in the position 1, 2. Then the covariance of x2, x1, that is in the position 2, 1. Then covariance of x2, x2, which is in the position 2, 2. So first we will find the covariance of x1, x1, which is equal to 1 by n minus 1 summation of k equal to 1 to n. Then x1k minus x1 bar, x1k minus x1 bar. So it is actually the square of x1k minus x1 bar. So this can be rewritten as 1 by 3. How we will get this 3? N is equal to 4 here, the number of data points. 4 minus 1 we get 3. Then 4 minus 8. So 4 is the data point. x1k, the first data point, minus 8. 8 is the mean. Then 8. 8 minus 8. Then 13. 13 minus 8 square. Then we have 7 minus 8. Okay, so it is 4 minus 8 the whole square plus 8 minus 8 the whole square plus 13 minus 8 the whole square plus 7 minus 8 the whole square, which is equal to 14. The next step is we will be computing this one, covariance of x1, x2. The covariance of x1, x2 is equal to 1 by n minus 1, and this is the formula. So here x1k minus x1 bar into x2k minus x2 bar. So we need to substitute. So the first parameter we have is x1k minus x1 bar. So here 4 minus 8 into x2k minus x2 bar. So here with x2 we have 11 minus 8.5. So we will get this one. Similarly 8 minus 8 into 4 minus 8.5 plus 13 minus 8 into 5 minus 8.5. So we get this one. Similarly, we get the next term. When we simplify it, we will get minus 11. Similarly, we find covariance of x2, x1. Covariance of x2, x1 is equal to covariance of x1, x2, which is equal to minus 11. Then we will be finding covariance of x2, x2. You can simplify this by substituting the values and we will get the value as 23. Now we need to fill up in the covariance matrix. So this is the covariance matrix. Here we will be filling up the values. So we will get S is equal to 14 minus 11 minus 11, 23. This is yes, the covariance matrix. Next, the third step is to calculate eigenvalues and eigenvectors. So to do this, we need to find determinant of S minus lambda I equal to 0. So this we will be doing. So to find out, first we will be calculating what is S minus lambda I. S already we have calculated as this is the S value. S minus lambda I. Lambda I is identity matrix. Okay. So we need to simplify it. When we simplify it, we will get lambda 0, 0, lambda. And now we need to do a subtraction of these two matrices. When we do a subtraction, we will be getting 14 minus lambda, minus 11, minus 11, 23 minus lambda. Okay. Then we need to take a determinant of it. So this is how we will be taking the determinant. It is in the position 1, 1, 1, 2, 2, 1 and 2, 2. So how we will take the determinant of this matrix? 1, 1 into 2, 2 minus 1, 2 into 2, 1. So we will get this equation. We need to simplify this equation. We will be getting a quadratic equation. Simplify the quadratic equation. We will get lambda 1 and lambda 2. Lambda 1 is equal to 30.3849. Lambda 2 is equal to 6.6151. Okay, these are the eigenvalues. Now we need to find the eigenvector. So the eigenvector will be u is equal to u1, u2. Okay, we need to find the eigenvector using this equation. S minus lambda I into u is equal to 0. So based on this, we will be finding the eigenvectors. So you substitute S. What is S? This is S. Already we have found out. And S minus lambda I. So we will be getting this equation or this matrix. And then U is U1, U2. UN U2 matrix. So we will be getting this matrix, and then we need to multiply these two matrix. When we multiply these two matrix, we will get this value, and we need to solve this for finding the eigenvectors. So the eigenvectors we get is U is equal to 11, 14 minus lambda. We can substitute the lambda value here. Which lambda value will be substituting? We will be substituting the highest lambda value. Okay. So first we try to substitute the highest lambda value, lambda 1. So, okay. Now u1 will be 11, 14 minus lambda 1, where lambda 1 is 30.3849. Okay. Now we need to compute the length of u1. So we will be computing the length of u1 is equal to root of 11 square minus 14 minus lambda 1 the whole square. And we need to do the calculation. We will be getting the length of u1 as 19.7348. Now we need to find the normalized eigenvector e1. So to find the normalized eigenvector e1, we will be doing 11 divided by u1 norm, then 14 minus lambda 1 divided by u1 norm. Already we have calculated what is u1 norm. So when you substitute the value for u1 norm, you will be getting e1 this value or this matrix. The same way you can find out for e2. Now the next step is to find the principal components. So how to find the principal components? You need to take the e1 transpose. Already we found what is e1. So the transpose of e1 into x1k minus x1 bar, x2k minus x2 bar. So we'll take the transpose of E1. So this is the transpose of E1 multiplied by X. We are doing for the first data point alone. In this case, we are going to find the principal component for the first data point alone. So the first data point is x11 minus x1 bar and x21 minus x2 bar. We need to multiply these two matrices. So when we multiply these two matrices, we'll get the equation this way, and then we'll substitute the values. So when we substitute the values, we get 4 minus 8. 8 is nothing but x1 bar. Then here 11 is nothing but the second feature, and then 8.5 is nothing but x2 bar. Okay, when we solve this equation, we'll get a value. This is said to be the principal component for the first data point. It means that we are reducing the dimensions. We are reducing from 2 features to a single feature. Okay, similarly, you need to do for all other remaining data points. So when we substitute for 8, 4 here in this here 8 and 4, okay, instead of x11, x21, we'll be using the second data point 8 and 4. We'll be getting this principal component. Okay, similarly we need to do for the third data point and the fourth data point. We'll be getting the single features or single principal component. In this case, what we are actually selecting? We are selecting the higher eigenvalue and its corresponding eigenvectors. So in this way, you can find the principal components for the given data set. Thank you.